Hello everyone. Today we'll be working on practice homework 5 in Stata. We have a problem about inclusionary zoning policies, and we will be using a differences in differences approach to determine the treatment effect of these policies. So, many cities in California have passed inclusionary zoning policies as an attempt to make housing more affordable. These policies require developers to sell some of the units below the market price on a percentage of new homes built. For example, in a development of 10 homes each with a market value of $850,000, the developer may have to sell 5 of the units at $180,000. Means et al. In 2007 examined the effect of such policies on house prices and number of housing units available using 1990 before policy impact and 2000 after policy impact census data on California cities. Use the data set means.dta to answer the following questions. Alright, before we get started, let's do a quick review of the differences in differences approach. So this figure kind of sums it all up for me. So we have two different subjects here, the top line and the bottom line. So in this case they're going to be cities. Point B represents the top city in the before period, where point A represents the bottom city in the before period. Point E represents bottom city after, C represents the top city after, and this D represents the top city if it had the same trend as the bottom city. So this bottom city is our control group, and this top city is the group with the treatment effect. It's a city in the group with the treatment effect. So if our common trends assumption holds, which is the key part of this diff and diff approach, then this top city would end up at D without the treatment effect, but because of the treatment effect it ends up at C. So this helps us determine a causal effect of a policy. And then if we look at how we calculate this, it becomes C minus E minus B minus A, because we're taking this big difference and we want to subtract out this small difference, which is the same as B minus A. So this becomes the average treatment after minus the average control after minus the quantity average treatment before minus average control before. So this Y variable is whatever outcome we're trying to measure, and the estimator is called a differences in differences estimator for the estimator of the treatment effect. And then here's this is just reiterating it, but we can also find these same quantities by running this regression model where we have the treatment effect, the time effect, and then the interaction of treatment and time. So it translates to this. So if we go back to number 1 here, we have, using only data for 2000, compare the sample price of LN price and LN units for cities with inclusionary zoning policy, IZ law equals 1, to those without the policy, IZ law equals 0. Based on these estimates, what is the percentage differences in prices in units for cities with and without the law? Remember that 100 times ln, the differences of the logarithms, is approximately the percentage difference between y0 and y1. Does the law achieve its purpose? So what is the purpose of the law here? We want to make housing more affordable. So we want price to go down. We want the law to lead to lower housing prices and more units. So first, let's start out by taking a look at our data. Here it looks like we have D is our indicator variable for the year 2000. So if it equals 0, then it's 1990. Equals 1, it's 2000. IZ law is the treatment indicator variable. So this is 1 equal to 1 if we have a city that had this policy in place. And then we want to compare LN price and LN units. So number 1, D equals 1 for the year 2000, just to keep that in our mind. And then IZ law equals 1 for inclusionary zoning policy. So we're looking at the year 2000. Difference in ln price and ln units. So we can do that by we can find the means by summarizing ln price if IZ law equals 0 and D equals 1. So this will give us our first mean, 12.2, and then we want to compare that to D is going to remain 1, IZ law equals 1. So it looks like where the law is present, we actually have higher prices. So that's the opposite effect of what we expected or what was intended by the law. And then if we change these to units, you can look at the effect on the total number of properties available. So in the presence of the law, there are more properties available. So in that case, it did have the intended effect. But this is just looking at the year 2000. So these are not causal. These cannot be interpreted causally. Use the simple rule that 100 ln y1 minus ln y0 is the approximate percentage difference between y0 and y1. So let's calculate that. So these cities with inclusionary zoning laws have, so we're going to take the difference in price, 12.89 minus 12.2851. Let's be precise here because we got to multiply by 100. And this difference times 100 should give us prices that are this percent greater, and units and blank percent more units, where this units is going to say the difference between 9.944, 9.994, 9 and 8, and it's 9.544865 times 100. So when we look just at the year 2000, we have greater prices in the presence of the inclusionary zoning laws, which is not what we wanted, but we do have more units. But the prices is the difference in prices is more than the difference in units. So it seems like the inclusionary zoning laws had an adverse effect. But remember, we haven't gotten to our differences in differences yet. So we don't know if that's causal. So if we go to number 2, use the existence of an inclusionary zoning policy as a treatment. Consider those cities who did not pass such a law, IZ law equals 0, the control group. Draw a figure like 7.3 comparing treatment and control groups and determine the treatment effect. Alright, let's look back at this figure from the PowerPoint. So we want to find this value, this value, and this value. C, E, B, and A. So treatment after, control after, treatment before, control before. So if we start with price, remember we have to do this for both price and units. Then we have IZ law, so the treatment after is going to be C. The non-treatment after is going to be E. Remember, non-treatment control after is E. Treatment before is going to be B, and the control before is going to be A. And we have to calculate the treatment effect D is equal to C minus E. Remember, we need parentheses here. Minus B minus A. So if we run all these, we're going to get 4 values, C, E, B, and A. So we're just going to plug those into our formula. 12.89 minus 12.28 minus 12.33 minus 12.06, and we can multiply this whole quantity times 100 to get the percent change in price that's due to our inclusionary zoning policy. So here we estimate 34%. Let's clean that up a little bit. So this is 34% increase in price due to the policy. We can do the same thing with the number of units. And then you just have to replace these means in here. We get 9.94994 minus 9.54. So that's the difference after. It's the difference in 2000. And then we have 9.899 minus 9.42. That's the difference before, and then the difference in difference we get is negative 2.9% decrease in units. So this is also a different value than what we got earlier. And these values tell us they're an estimate of the causal effect of the treatment of the inclusionary zoning policies, rather than just comparing the means in the year 2000. So if we go to number 3, use ln price and ln units in difference regressions with explanatory variable D, indicator variable for 2000, IZ law, and the interaction of D and IZ law. So we're going to try to find the same effect using the regression method. So number 3, all we have to do here is regress ln price, IZ law D, and IZ law D, the interaction of those two. And we should get that the coefficient on IZ law D is the same as the coefficient that we got this 34%. So should be about 0.34. And when we run this, we get 0.332. So this is just based off of how many significant digits I used earlier. But that's basically replicating what we did earlier in the form of a regression. And then we can do this for units. And we should get the negative 2.9% as the coefficient, as the treatment effect here, and negative 3.1%, so pretty close again. So here is just showing you that you can do this either by the comparison of means or by a regression. You still get the same differences in difference treatment effect. And then if we go to number 4, add the control variable median household income. So now we want to control for the median household income of a city and see if that affects our treatment effect. So we're just going to replicate these regressions, but we need the variable ln median household income as part of both of our regressions. So we can just copy and paste that. And then when we run the price, we now get a smaller treatment effect. So these prices have increased by 23.8% instead of the 33% that we measured earlier. And then units, we will see that it's a little bit more negative, so 3.4% decrease in the number of units. And we find out that inclusionary zoning policies in this case have the opposite effect of what they're intended to do. So we saw a significant increase in price and not much change in the amount of units. So this is not significant. The increase in price due to the law is significant. So we see housing prices go up 23.8% as a result of these laws when they were intended to decrease the prices of housing in a city.